So how do we find the derivative of y is equal to secant x raised to the x power? I actually put this question on my quiz for the calculus class that I'm teaching during the summer, and the result is about half and half. Half of the students got it right and half of the students didn't get it right. So here I would like to just show you guys two ways to go about doing this. First way, this is the way that I showed in class. Start with y is equal to secant x raised to the x power. The trouble with this function is the base is a function because we have the x, right? Secant x. And the exponent is also a function, namely x. So we do not have a direct way to do it yet. What we can do is take natural log both sides. Because this way, we can put the exponent to the front and it becomes a multiplication. We get ln y is equal to x times ln of secant x. Now, the y is no longer isolated, but it's okay because we can just do implicit differentiation. I will put down d dx like this to mean we are differentiating with respect to x. ln y will give us 1 over y, but we have to use the chain rule, multiply by the derivative of y with respect to x, which is the dy dx. And then on the right hand side, notice we have x times ln of secant x. So we will have to use the product rule. I will keep the first function, which is x, and then I will multiply by the derivative of the second. Derivative of ln of this, first we do 1 over whatever this is on the inside. And I usually show my students that imagine we have a box. The derivative of ln of a box is 1 over the box. And then use the chain rule. We have to multiply by the derivative of the box, which is going to be the derivative of secant x. Yes, it's over there. But anyways, well, it's on my back too. Yeah, let me just show you. Anyways, the derivative of secant x is secant x times tangent x. So you have to know this right here really, really well. And then you continue. You add the second function, ln of secant x times the derivative of the first, which is just going to be derivative of x is 1. And that's pretty much it. However, we notice that secant x cancel, and usually we like to get dy dx by itself. Here we have 1 over y. Let's multiply y both sides. Multiply both sides by y so that you can cancel out this and that. And now we have dy dx that's equal to y. And you can rewrite y as the original because y is secant x to the x power. And then you multiply by the rest. So here we have x, and then this is just tangent x. And then we add this times 1, which is just ln of secant x. And that will do it. This is the answer for it. Okay, so what's the other way to do it? Let's have a look. Here we go. Secondly, we can look at it like this. Y, which is equal to the base is secant x and then raised to the power x. In calculus, we do not like to have base anything else besides e. I know there's an e, but this is secant x. We don't like that. Here's the trick that we can do. We really like to have e for the base, put e and also ln together, and you just put whatever this is on the inside of the natural log, like this. Why? Because e and natural log cancel, so you really just get secant of x back. And then you raise this to the x power. Now notice, here we have an exponent on the inside, and then raised to another exponent. So you can just multiply the exponents. So we get e raised to the x times ln of secant x power. Y is the same as that. So to get dy dx, because y is just by itself, we can just go from here to here. It's like d dx and just get that. And then just take the derivative of this thing, the usual sense. So this is slightly more direct in my opinion. Firstly, e to the something, right? It repeats first, so e to the box. You get exactly the same thing. And then we have to multiply by the derivative of what's inside of the box. But notice we need to use what? Product rule. Here we go. First, we have x. And then we have to multiply by the derivative of the second function, which we get 1 over secant x. And then again, this is ln of like a box. So you multiply by secant x tangent x. And then you add the second function times the derivative of the first, which is just 1. Yeah, so it's just like that. Now we can simplify it pretty nicely. What's this though? It's just that, which is just this, which is really just the original. So this is secant x raised to the x power. And then right here, once again, we see the secant x cancel. Of course, it's pretty much the same step now. And then we just add secant x like this, and then we're done. Just like that. So let me know which way do you like it more.